All right. So, welcome back to our series. So, this will be Cisco Certified Network Associate 2025 Guide, Day 3. So, for today's episode, we're going to focus on the IP address. Okay. So, IP address and also what is subnetting. So, IPv4 stands for Internet Protocol version 4. So basically it's the fourth version of this protocol, and this is what we are using right now. Though we have IPv6 already coming out, and it's already been used for quite a while as now, but still uh, there's still a lot of IPv4 that's being used for on our current network architecture. So we'll be focusing on the IPv4 or Internet Protocol version 4. So IP address, so by the name itself, it's an address. So it's a way for us to locate a certain machine, a server, a PC, a computer. So every machine, computer, or device, they do have their own IP address. That's the only way for us to know the location or for us to reach that specific machine. For example, on my device, if I'm going to type CMD and check for IP config, I'm going to see that my IP address is 192.168.1.7. So that's my IP address. And by default, if you're going to go to the ncpa.cpl, so this is a network settings, go to the properties of your Wi-Fi connection. If it's an Ethernet, just go with the Ethernet one and go with the Internet Protocol version 4. So that's the TCP over IP version. You're going to see here that your IP address is set up to receive automatically by the router. So right now we're just receiving IP address based from the provided IP of that specific device. But by default, you can also change that. So like that, 1.10, and you just basically okay here, and your IP address will be changed. But we're not going to do that now. We're going to focus on the structure of an IPv4 or like an IP address. So as you can see, this is an example of an IP address. So it's divided into 4 group, and each group we can call it as an octet. So an IP address is basically 4 octets, so meaning 1, 2, 3, and 4. And what we mean by octet, it's basically representation. This one, it's just a representation of octet value. But it's octet, it's because if you raise 2 by 2, 2 times 2 times 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So if you're going to 2 raised to 4, 8, 16, 32, 64, 128, and 2, 5, 6. Okay, so it's an octet because the maximum value that we can that it can contain would be 256. Now, for IP address, that's going to be 255 because we're going to start always with 0. So 0 to 255, and the total value that certain block can contain would be 256. So it's an octet because it's raised 2 raised to the power of 2, then times by 2 times by 2 until you have the value of 256. And again, if we're going to go back on our previous topics, we mentioned that we know that the IP address or like a machine can only understand binary language, and this one is a representation for us to easily identify what is an IP address. But if we're going to look this one on a machine level, 192, that means let's say, so it's going to be 128, 64, 32, 16, 8, 4, 2, and 1. So it's always raised by 2. And if we're going to represent this one by bit, just basically 1, 1, 0, 0, 0, 0, 0, 0. Why is that? It's because when you add 128 to 64, this basically 9 is basically 192. So the value of this is equivalent to this one in the machine level. So same goes with this one and this one. You just need to check which value that if you add it up will result to this value, and that's the equivalent binary value of that block for that specific IP address. Now, how do we know if how can we like connect one IP address to another? So the only way for us to know that is by using the subnet mask. So subnet mask, it's a basically says divided into network level. So this will be the network, and this would be the host. Okay, so if you're going to check, okay, what is the network of this IP? So you always have to look with the IP subnet mask. So for this one, 255.255.255, so it means that your subnet mask would be 192.168.1. So this one is the network. So any value that you change here, like 19, 1, 8, 254, that's going to be on the same network. And if they are on the same network, they basically can connect to each other. So let's go to the packet tracer, because we have a different IP class. We're going to focus on A, B, and C. But this one, because what's the most widely used IP address right now would be the class C network. Do I really need to log in? Oh, let me check. Let me just off my internet connection. I think putting it off will allow me to use my packet tracer, right? What? No. Let me try one more time. Okay, here we go. Oh, no. Why? Am I okay now? Oh, I'm okay now. I'm able to use it. Okay. Okay, let me provide examples. Let's go with the host machine. And I'm just going to use a regular cabling. So if we're going to add like 192.168, 192.168.1.10, then 255.255.255, and then this one 192.168.1.8, let's say. So this is the .8. Go back to command prompt, ipconfig. My IP is 168, and my IP here would be .10. Okay. So if we're going to ping the .10, ping 192.168.1.10, so basically you can connect to each other 1.8, because so if it's on the same network, they basically have access to each other. That's the simplest way to look at these IP addresses. Now, like what I mentioned, it's going to be based on the subnet mask. So if you're going to change this on 2.8, and I'm going to ipconfig, my IP now is 2.8, and I'm ping that IP, even though I have direct cabling connected, I'm not able to reach that IP address. So it's going to be request timeout. So in short, the only way for us, the basic network connectivity of an IP address, if they are on the same network. And for us to know if they're on the same network, you have to look at the subnet mask. 255.255.255, that's basically a class C subnet, which is, this is like a class A if it's on, and then 00. Class B if it's 255.255, then 00. Class C, it's because 255.255.255, that's 0. Right? So now reason why we're always seeing like the class C network, so class C, is because if you're going to, or if you have observed, the maximum host of this or IP address that it can contain would be around 254. So maximum of 254. It's always -2 because the first IP, the .0, that's going to be the network ID. It's like an identifier for that specific network. And the last IP would be the broadcast IP. So the broadcast IP for this one would be the .255. Okay, so that's why maximum of hosts it can contain would be 254. So it's always class C because on a typical home setup, we really need like a lot of IP addresses, and right now even the 250 is already a huge amount of IP already. Right? That's why we're always going to see class C network. And also a reason why we have to subnet is because these 254 IP, imagine you have a company, let's say you have a company and you're only using like maybe 50 or like 100 PC, and then you're going to use a class C network. So it means that you have 120 IPs that are not usable. And just to give you an idea why this one is not the best practice is because the last IP, like the 255, that's the broadcast IP, and by definition, it's a way for us to send multiple, or it's a way for us to send broadcast message to all part of the network. So it means that, okay, if I have a broadcast message, okay, maybe I need to update or I need to ask certain information to the whole network. So those all IP address will send the broadcast message, but considering that you only have like probably around 50, but you're sending like 250 packets for the specific network. And that's the main reason why subnetting is important. So basically subnetting, you're just dividing a network to a subnetwork just to make sure that the IP address would be much more less than the default. The default for class C, that's going to be 256 or 254 hosts. So if you're going to subnet it, you can subnet the value. Maybe let's say we have a problem number 1, and then on a problem number 1, let's say the IP address that I needed would only be 100. So if 100 is the IP that we needed, we can borrow subnet to the last network. So if we're going to do that, so it's 256 is the default value. So if I needed around 100, I need to check what's the next value for the octet. So that's going 128, 64, 32. So I need to jump to this IP. And if you remember, the subnet mask for class C would be 255, 255, 255. Now, if I'm going to borrow here, so instead of 0, I need to check what would be the corresponding value. So for this one, the corresponding value, since it's going to be an octet, you just basically divide it by 2. So it's going to be 128. So 255, 255, 255, 255, that 128, it's basically equal to 126 hosts. So that's going to be the subnet value. If the problem is, okay, I only need 100 IP, so I can use this subnet mask so that we can divide our network. So we only have 1 to 127. So 127, that's going to be the broadcast IP. Since that's the last IP, 1 would be the network. So the host IP, 0 would be the network. So it's going to be 1 to 127. That's all the IP that we can use for this specific subnet. So if you're going to apply that here, let's say, let's put it back on the same network first. Uh, okay, 1.8 like this one. So since I put them back, so they will be able to ping each other like what we are expecting. So IP config, ping 192.168.1.10, ping 192.168.1.8. So if we're going to subnet this, let's say 128 and then 10, then subnet this 128. Do you think that they can still ping each other? Let's see. So I'm going to ping the same IP. So I can still ping the IP from 1.8 and 1.10. So why is that? Because it's still on the same network. So the next network for this one, if we're going to change the value to, let's say, 132. So if I change the value to 132 and I ping 192.168 that 1.132, as you can see, my IP would be 1.132. So right now, even since because of the subnet, we're basically not able to ping now this 132, because the first network, it's only up to until that 126. Okay, so that's the basic of subnetting. But I hope you get the idea of it. We're going to have a deeper discussion about that one, but I just would like to provide you like an overview on what is subnetting and how can we apply it on a packet tracer and also in real life. But that's basically how it works. We subnet because we would like to optimize the number of IP addresses used for a specific network. So ideally, you would only would like to have extra IP, but not too much for that specific network. Again, for the reason that the more accurate your network is, the faster it will be, especially if there will be huge traffic involved on that specific network. So that's the purpose of subnetting. Now, aside from that, compare TCP and UDP. So I've mentioned this before. The only difference between the two is that TCP is connection oriented and this one is connectionless. So if you're going to load a YouTube video, let's say a YouTube site, the web page, like the icon here of YouTube, like the videos here loading, like the design, that will be TCP. Now, if you started watching video, like you're playing video, that's going to be UDP because it's going to be connectionless. So you don't like your video to keep on stop, or if you're like doing a live stream video, instead of like doing the delay and all, it's okay to have a jump from the video instead of pause and stop and play, and instead we're focusing on giving it as real time as possible. And here, what I can suggest for you to understand that network more, if you're going to type netstat on your laptop and you started browsing on your computer, you're going to see what are the protocol used. 127, that's basically your own IP address, and you can see if it's using TCP or UDP once you're watching video. So I'd like you to do that. Go with your CMD, browse as many websites as you want, and then check the status of the protocols that's showing on the CMD after that. Okay, I think that's all for today's topic. So it's an overview of IP address. I might do another topic for this one because this one is huge topic, especially if we're going to involve different IP classes. And I think that's for now. Thank you again for watching our Cisco series 2025. Thank you, everybody.